in the previous video, somewhere I have mentioned that we have parallel uh, sprue over here, from where the metal is going to flow from the pouring basin to the actual mold. Over here, the plane is parallel. The two lines are, or there is a cylindrical system. But when we have D2 is equal to D3, that means that was what assumed earlier, that the diameter at this location is equal to the diameter at this location inside the pipe, from where the mold is the melt is going to flow. And hence, if we apply, even if we apply the Bernoulli's, the velocities are going to be equal, right? Because A1 V1 is equal, A1 V1 is equal to A2 V2. That is the continuity of mass. The mass which is flowing at location 2 is equal to the mass flowing at location 3, because it's not going anywhere else. And since the mass flow is area into velocity, since the areas are equal, the velocity must be equal. That's how I'm going to claim that. And in that case, when we write the Bernoulli's equation, P2 V2 H2 term, P3 V3 H3 term, and H3 is 0 because of obvious reasons, that we are taking the reference at location 3. And hence my P2, the pressure at location 2, is equal to minus rho G H2, which is the gauge pressure. And this is a negative pressure. That means it's negative with respect to atmosphere. It's not absolute negative pressure. It's negative with respect to atmospheric pressure. So when the sand is heated up, and when it be heated up, when we are going to pour the metal, obviously the heat will be transferred to sand also. So the sand is heated up, and sand has moisture contents, and there is water. That is water. When it is getting heated up, the water will convert to vapor, and then vapor gets embedded into molten, the molten part, which is being poured, and which is not preferred. That means there is one of the defect which can occur because of this, which I have explained in another video. So this vapor gets dissolved into the molten state of our metal, and that is not preferred. That is dangerous. That weakens our mold. So to counter that effect, the pressure which is getting negative, we are going to have a special kind of design, which is a tapered or a draft. So the thing which is going to happen is called aspiration effect, which is sucking of the bubbles. The bubbles which are formed inside the mold, the bubbles are of vapor. Those are formed inside the mold, and because of the pressure difference, the negative pressure inside the pipe. So over here, the pressure is negative, or over here that was atmospheric pressure somehow. And because of this pressure difference, the bubbles will be sucked from this location inside the mold, or inside the melt which is flowing. And to avoid it, the shape of sprue, this is the sprue, obviously you know that, which I have explained earlier also. The shape of sprue pin should be changed, because the pressure in liquid stream over here is less than the atmospheric pressure. They absorb the gases from the baked sand. This is the baked sand, because when we are going to pour the metal, the melt, it is at high temperature. That's the reason the heat transfer will have occur, and the sand will be baked. So now we need P2 minimum. The minimum pressure over here equal to 0. That is, the gauge pressure should be at least 0 or positive. It can't be negative. So let's write again the Bernoulli's equation between the location 2 and 3. P2 is equal to 0. That's what we want. It is not 0, but that's what we want. And P3 is 0 because that surface is open to atmosphere. Now let's make put in all the values which we know. So V2 square by 2G plus H2 is equal to V3 square by 2G. Because this term is 0, this term is 0, H2 remains, V2 remains, V3 remains. This term is obviously 0 because the reference height is taken from 3. Now, obviously, still the metal which is poured from here is going to exit from here. So material continuity is there, mass continuity is there, and hence V2 A2 is equal to V3 A3. That should occur because the density is not changing. Hence, let me substitute V2 is equal to A3 by A2 into V3. And I'm going to use R is equal to A3 by A2. That is one of the another constant I'm making. So V2 is equal to R into V3. Now I'm going to substitute this over here. and r square v3 square by 2g minus taking this term over here, this term over here. That's what I've got. Minus r square plus 1 by 2g into v3 square is equal to h2. And the shape of the sprue because of this equation is something like this. It is a parabolic. We can simplify this and we get r square is equal to 1 minus 2g h2 upon 2g ht. Ht is the total height is equal to 1 minus h2 by h3. h2 by h3. ht and h3 ht and h3 are the same. h3 is the height between 1 and 3. ht is defined in the similar way. So we have got that equation r, and when we substitute r over here, obviously when we use r over here, r is having a squared terms, square root term, so that becomes a parabolic, because on one side we have power 1, another side we have power 2, so it will become parabolic. a3 from here, a3 by a2 will be hc by h3 because of this. So from there I am making the inference. From here I go here, and that's how my a3 is equal to a2 into hc by h3. hc is smaller height, h3 is the larger height, hence my a2 will be larger, a3 will become smaller. So whatever this constant value is into a factor which is smaller than 1, which means a3 will be smaller than a2. Fine. So that's how I have derived the thing. And let's solve a question. We'll solve the question in the next video. Okay, thank you.